Hello, this is Ms. DB. In this video, we are going to learn about geometric sequences and series. So earlier in this quarter, we had an assignment about geometric sequences already when we did the exponential functions unit. So we won't spend a lot of time on geometric sequences, just kind of a review. And then we'll also learn about geometric series. And let's see, so geometric sequence is when a sequence in which the ratio of successive terms is a constant ratio, called the common ratio, and the common ratio can't be 0 or 1. And you can find the sequences in a geometric sequence by taking the previous term and multiply by that common ratio. And if you want to find the nth term of a geometric sequence, like you don't want to write out all the way until you get to number 10 or number 15 or number 100, then you can use this formula, which is very handy. So it says that you take a given term is equal to the first term times the ratio to the exponent of n minus 1. So if you wanted to find the 10th term of a sequence, you would use, this is the first term, whatever number you start with, you have to know that, and you would multiply that by the common ratio to the, if I wanted the 10th term, I would do 10 minus 1 or the 9th term. So the ratio to the one less than the term you're looking for. And make sure that you find this first on your calculator and then multiply by the first term. Don't multiply the first term times the ratio and then raise that to the power. You'll have way too big a number. So here's some examples where you're going to find the nth term of a geometric sequence, and this is what we did earlier this quarter. So we won't spend a lot of time on this. Sometimes you have to find the common ratio first, it's not given to you, and you do that just by dividing any term by the one before it. It doesn't matter which one you do. I could take negative 20 divided by positive 10 and get negative 2, or I could take, like they did, the second term divided by the first term and they also get negative 2. You should get that for no matter which way you find your common ratio. And then we're going to write the rule, plugging in our first term of this one is negative 5, so that's where the a sub 1 goes. And then the common ratio is negative 2. And if they're looking for the 9th term, we take 9 minus 1, or 8. So the first thing you have to do is the negative 2 to the 8th power, and they got 256 for that. And then you multiply that by negative 5. That's how you get your 9th term. All right, so we're going to do that for number 1 and 2. You're going to find the 8th term of each of these. And then in 3 and 4, you're going to find whatever term they ask you to find. So like in number 4, first we have to find the common ratio by dividing any term by the one before it. That's how you'll get R for A. And then the rule for the sequence will be A sub n is equal to A sub 1, which is 243, times R, which we'll get from here, to the n minus 1 power. So all you have to do to finish B is plug in what you get for the ratio. And then for C, we want A sub 8. We're going to use the same formula. R will be whatever you got from before. And then for the power, instead of n minus 1, you'll have 8 minus 1, so that'll be to the 7th power. And then you'll calculate this part first on your calculator, and then multiply that by 243 to get your answer. And this will be a decimal number, 108 divided by 162, so that's fine to use for R. All right, then we have a little bit of a section on geometric means. And you might have learned about this in geometry class. The geometric mean is when you multiply two numbers together and then you take the square root of that result. And that has to do with geometric sequences. So A and B are positive terms of a geometric sequence with exactly one term between them, then this is the geometric mean. And you can either simplify your square roots or you can get a decimal answer, rounded to 1 or 2 decimal places. So here's another example using fractions. You multiply these together and then take the square root of that. So for these problems, you're going to just do that. It's just practicing finding the geometric means. Like in number 7, you multiply them together. This will give us a positive number. We can't take the square root of a negative number and get a real number. So negative 5 times 45 will be positive 225. And then take the square root of 225, and I happen to know that that is a perfect square. is, it's 15. So sometimes you'll get a nice integer answer, and sometimes you'll get a decimal. All right, and now we are going to find geometric series, the sum of the first so many parts of a geometric series. So we've already learned about what a series is. A series is when you have a sequence with all the terms added together. So here's an example of a series. It starts as a sequence, and then you just replace the commas with plus or minuses. So 3 minus 6 plus 12 minus 24 plus da 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 da. Another way of writing a series is with the summation form, which we've looked at before as well. So this says, the way you would read part B, is that this is the sum of the first to the fifth terms of this sequence, 1/3 to the k minus 1. And then we'll replace k with 1, with 2, with 3, with 4, and with 5 in order to find the sum. So you could do this by hand. You could write out all of the terms and then add them together. But we also have this formula that we can use so that we don't have to, especially if there's lots of terms that we would have to add this for. So the way that this formula works is you take the first term, that's a sub 1, and r is the common ratio. So you'll either be given that or you'll have to find that. And then you are going to use this formula, 1 minus the common ratio to the nth power, which will match the number of terms you're looking for, divided by 1 minus r. And r can't be 1 in this case because then we would be dividing by 0, which is not allowed. Let's do this for number 10. So I'm going to write this. Actually, I'm just going to copy this and put it closer to the problem so I can see them both at the same time. All right, so for number, oh, I did put the question here, or the formula there. Okay, so it's handy to look at. So we have to find the common ratio. To find the common ratio, you're just going to take one term and divide it by the term before it. So 126 divided by 42. We can double check that we get that same ratio when we do like 42 divided by 14. We should also get 3. Yep, we do. Okay, so the common ratio is 3. What is a sub 1? That's the first term in your series, so in this one it's 14. And they want us to find the sum up to 7, so the first 7 terms. So we're going to use s of 7 is equal to a sub 1 is 14, and then in parentheses we need 1 minus the common ratio of 3 to the n power. So that's 3 to the 7th, n is 7, and r is 3. And that's all over 1 minus the common ratio. Now how would I write this if I was typing, if you were using, the word tools? So s of 7, that's capital S of 7, we have a subscript button here, so I can do the 7 like that. That's the easiest way to do this. It's equal to 14 times, now I'm going to have a fraction in here. So let me change this to a square bracket. The numerator is going to be 1 minus 3 to the 7th power. And that's all going to be divided by, the denominator is 1 minus 3. And that'll close my brackets. All right, so that's an example of how you would use those formatting tools to write that out. You could also use the insert equation tool if you want to. I'm going to keep using my pen. So 1 minus 3 to the 7th power is 1 minus 3 to the 7th. Don't take 1 minus 3 and get negative 2. 1 minus 3 to the 7th power. So I need 3 to the 7th power. 3 to the 7th power. So on your calculator, look for an x to the y button, or maybe an exponent button. And that's equal to 2,187. And that's all divided by 1 minus 3, which is negative 2. Don't try to do too many steps at once here. So 1 minus 2,187 is negative 2,186. And that's divided by negative 2. So I need 1 minus 2,187. And that number divided by negative 2. So negative 2,186 divided by negative 2 will be a positive number, 1,093. And now I can multiply these together and get 15,302. And that is my answer for number 10. So the place where most students make mistakes is up here. They do 1 minus 3 is negative 2 and take that to the 7th power, which will give you the wrong answer, a very different answer. And then also, for some reason, a lot of people make mistakes here, and they'll call this, you know, a positive 2,188, or they add or something. So be careful in these areas. And it wouldn't make sense, this is an increasing series sequence. They're getting bigger and bigger, so it wouldn't make sense if your answer came out to be a negative number, would it? So watch that. Now let's look at one that's in summation notation, like number 11. This is telling us that we want the sum of the terms from 1 to 8 of this expression, negative 4 to the k minus 1. So the first thing we have to find is the first term, which is when k would be equal to 1. So if I put a 1 in here, I would have negative 4 to the 1 minus 1, which is negative 4 to the 0, which is equal to 1. So this equals 1. So a to the 1 equals 1. Not 4, not negative 4. Because when k is equal to 1, I got negative 4 to the 0, which is 1. All right. R is the part that is being raised to the power. This is r, negative 4. So that's what we're going to use for r. They want the n to be 8 because they want from 1 to 8. So now we use this formula again with these values. So we're going to use a sub 1. We found that to be 1 to the 1 minus r. R is negative 4 to the 8 power all over 1 minus negative 4. So watch your negatives on this. This is s sub 8. So the 1 times this is not going to change our answer. Multiplying by 1 doesn't change your answer. So at this point you could just know that it's just going to be 1 minus negative 4 to the 8th power over 1 minus negative 4. So the denominator is going to be 1 plus 4 because minus a negative. So 1 plus 4 on the bottom. On the top we have 1 minus. Don't change that to a plus because this part needs to be done separately. So we need negative 4 to the 8th power. So on my calculator that's on my computer, I have to type a 4 and then the negative sign. And I really need parentheses around that. So I need 4 negative parentheses. Now it looks like it should. And I need that to be to the 8th power. You might do it slightly different on a handheld calculator, but we should get a positive answer because a negative number raised to a positive power, an even power I mean, is going to be an even number. So 65,536. Now note that we still have to do 1 minus that, and that's all over 1 plus 4, which is the same as 5. So 1 minus 65,536 is equal to a negative 535. And does that make sense that our answer is looking like it's going to be negative? Well, we are taking the sum of a sequence that has a negative ratio. So if we had written out the first few terms of this, we're starting with 1, we found that. And then we have to take negative 4 to the 2 minus 1. That'd be negative 4 to the 1 power, so that'd be negative 4. And then we would have to take negative 4 to the 3 minus 1 would be squared. So we'd have negative 4 squared, which is a positive 16. And then we keep going. So they're going to alternate positive and negative. And if we're ending on 8, the 8th term, that will be a negative number, and it's going to be a pretty big negative number. So it does make sense that our sum would be negative. All right, so now I need to take that number and I have to divide it by 5. And I get negative 13,107. Negative 13,107. And I had to multiply that by 1, but that won't change my answer. Because my first term is 1, that's why I'd have to multiply that by 1. So that's how you'll do these problems. Find the common ratio, find the first terms. If it's listed like this in a series, then you can say the first term is just the first number. If it's in this kind of thing, then you have to find the first term by putting 1 in here, and 1 minus 1 is 0, and anything to the 0 power is 1. So in number 13, your first term is 1 as well. All right, and number 14 is a word problem, but it is a series, so it's going to be done the same way. So we can start the first series out by starting with 10, and then so on. So you can figure that out. So the common ratio in here is 10. And then you'll solve it the same way as the other ones. So if you get stuck in any of these, let me know, and have a wonderful day.